What? Hmm? Good morning, Alec. How are you?
I'm good. How are you?
I'm good, thank you. Better than yesterday, that's for sure. Sorry about yesterday. Good morning, Clara Jane.
Good morning. Let me turn
How
on
are
my.
you? Oh, you're good.
Are you feeling better this morning?
I am feeling better, thank you. I'm not 100%, but I am better, and so that is. I'm just still a little tired from the day, but I'm doing much better, thank you. I ended up going and getting a COVID test. Fortunately, it was negative, so I just figured for peace of mind, go ahead and take care of that, make sure it wasn't anything other than just a stomach bug. And I guess
Yeah.
it was. So anyway.
Last week, we went camping in
Uh-huh.
Georgia, and my mom kind of got a little sick.
Yeah.
She decided to go home because she didn't want to get her parents sick.
Mm-hmm.
So, but she went to the doctor and she tested negative for COVID. So,
Good.
that was
Yeah,
really good.
yeah. I know there's other stuff going around, but now every time we start feeling bad, we expect it to be COVID.
Yeah.
I'm ready for that to not be the issue anymore. But anyway, it is what it is. So I hated canceling class. I'm sure that y'all were all totally torn up about it, but have one more day. Oh goodness. We'll wait and give everybody else a chance to log in. My plan is to start with kind of reviewing, starting at 6-1 and kind of reviewing what we've looked at. So that's where we'll start. Here everybody comes. Good morning, Lucas. Morning, Tyler. Let's see. So April and Easton. 1, 2, 3, 4, 5, 6, 7. And then Keely. We'll give it another couple of minutes, let everybody get logged in. Everybody's probably checking their email, trying to see if we're having class today. Well, it doesn't look like anybody's coming in just yet. So, all righty. So I'm going to try to refresh my memory on where we left off a week ago, week and a half ago, 2 weeks ago, I guess it was 2 weeks ago. So anyway, if I recall correctly, I had taken up homework for chapter 5 and y'all had gotten the chapter 5 test, right? And then the chapter 5 test, y'all still need to turn in. Is that correct? Okay, because I was looking through. So what I will do is I will put a place to upload that. Let me do that real quick. And if anything I'm saying is not correct, y'all tell me if I'm not remembering correctly.
I submitted the test yesterday, but I couldn't find a place to like put it on the website, so I just emailed it to you.
Perfect. Really quick, I'll go ahead and make that place. And so we'll have it. Let's see, that will be for geometry. And new assignment. That'll be test 5. Today is the 3rd. And we'll save it. Okay, so there's a place for that to go now. So I have collected chapter 5 work, test 5. We've gotten that done. And so what I'll do is I will start checking those and have those back to you guys for corrections. And then we had started with chapter 6. Okay, so let's go ahead and start on page 322. Let's go ahead and start with 6.1 and do a quick little review of where we are. We finished up with triangles in the previous chapter, and now we're moving on to quadrilaterals. But one of the things about quadrilaterals is we're finding that we have actually a lot in common and we can transfer over.
Didn't we have homework on this section?
We did. So as we go through it, we'll check it.
Okay.
So real quick, let me pull up my screen real quick. Why is my... Okay, there we go. All righty. Come on. Okay, so 6.1, dealing with polygons is where we're going to start. Okay, so we talked about how a polygon has sides. Each side is a straight line that connects with another line at a vertex. Plural is vertices. We talked about how we name our polygons based on the number of sides that we have. Let me pull this up real quick so I can make sure I see anybody that needs to come in. So here comes Keely. Good morning, Keely.
Good morning.
All right, so we are starting with a review of chapters, starting with chapter 6.1. We just kind of did a quick recap that we've already collected the chapter 5 homework. Chapter 5 test, I just put a place on the website to be able to upload it if you need to do that. So all of that is there. And we were talking about how 6-1, dealing with polygons, we have figures made of a number of sides. Our smallest polygon is going to be our triangle, 3 sides. And so we name our polygons based on the number of sides that they have. So when we moved on, we looked at the difference between a convex and a concave polygon. Convex was if you extend the sides out and all of those extensions are outside of the figure. Concave is if I extend a side of my figure and it goes through the figure, then that's called concave. We talked about how to identify a regular polygon. A regular polygon is one that has sides that are all congruent and angles that are all congruent. So if I have congruent angles and congruent sides, we call that a regular polygon. We talked about diagonals of a figure. We talked about how we have the points that connect the consecutive sides. So if it's side to side, that's just a side of, and I connect a point, that's just a side of my figure. But when I connect a point to another point that is not directly next to it, that forms diagonals. And so we looked at the different kinds of diagonals that we can connect. We also talked about how the interior angles of a quadrilateral, so we have 4 angles. And so if we have 4 angles and each angle was 60 degrees, I'm sorry, not 60 degrees, each angle, so think about when with a rectangle, we have a rectangle that has 4 90-degree angles, and then 4 times 90 is 360. So I don't know if that'll help you to remember the difference. Like a quadrilateral, always kind of go back to a square or a rectangle. You know it's made up of 4 90-degree angles, and 4 times 90 is 360. Therefore, all quadrilaterals have an interior sum of 360. Okay, and so that's what theorem 6-1 tells us, just that if we add up the measures of each angle, whether they're all exactly the same or not, it's going to total 360. Knowing that it totals 360, we looked at how to set up an equation if we're needing to solve for one of our variables, and we just use the same format of angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. Plug in the values that you have, whether they're variables or actual numbers, and then solve. And so on this section, we had a little bit of homework. We had 21 through 35 odds on, let's see, this is page 326. So that's where we will start, 21 through 35 odds. So any questions on these? They were all odds, so they were in the back of the book. So I guess there's not any that we need to go over, but unless you have a question about something. All right, we will move on. So then we moved on to the next page and had 37 through 45 odds. Any questions on these problems? 37 through 45 odds. Again, they were in the back of the book, so hopefully you've had a chance to check them.
I had a question on 45.
Okay, let's take a look at 45. All righty, so we've got 4 angles here. Okay, and remember we just talked about how the angle sum theorem tells us that I just add angle 1, 2, 3, 4, and they equal 360. So in this situation, I know that first angle I've got, oh, let me get my pen going. I know that my first angle I've got, ooh, not that big. I have 82 degrees plus 25x minus 2, and I guess I don't even need to worry about my degrees right now, plus 20x minus 1 plus 25x plus 1 equals 360. Okay, so I set them all, add them together, equals 360. So now I'm going to combine like terms. I've got 82 minus 2 is going to give me 80. 80 minus 1 gives me 79. And 79 plus 1 is going to give me 80. And then plus, I've got 25x plus 20x is 45x 45x plus 25x is going to give me 70x. So 80 plus 70x equals 360. I'm going to subtract 80 from each side. Let me move down where I've got a little bit of space. So I'm going to have 70x is equal to, let's see, that's going to be a 16 and a 2. That's what, 280? Divide by 70, divide by 70. And so x is equal to 4. Okay, so I just set it up, even though I've got all kinds of variables in there, I just set everything to where I'm adding them up equal to 360, combine my like terms, and solve for x. Does that help, Alec?
Yes, ma'am. Thank you.
Perfect, you're welcome. Any other questions on this page? All righty, so then we moved on to 6.2, properties of parallelograms. All right, so still our whole unit is about quadrilaterals, so our whole unit's about four-sided figures. Now we're looking at particular four-sided figures, and this first one is talking about a parallelogram. The main thing that I know about a parallelogram, other than that it's a four-sided figure, is that I know that the opposite sides are parallel, okay? So I have two pairs of parallel sides that are opposite from each other, or two pairs of opposite parallel sides, whatever you want to call it. And so whenever you're looking at these, it may be a picture indicates with the two arrows, or the two sets of arrows, or it could be that you just notice that the measurements are the same. So I've got two congruent sides that are parallel to each other, okay? Now, knowing that, we can look at the theorems based on parallelograms, and we see that not only are the opposite sides congruent, but we see that opposite angles are congruent. So I know that my angles that are across from each other are also going to be congruent. And then we looked at theorem 6.4 that said consecutive angles of a parallelogram are supplementary. Remember, supplementary means that they add together to equal 180 degrees. Therefore, when I look at this one, I can see that if I add angle P to angle S, I'm going to get 180 degrees. Same thing if I were to add Q and P, because those are consecutive, those are side by side. Those would also equal 180 degrees, okay? So knowing that consecutive angles are supplementary. And then the other thing we learned was that the diagonals of a parallelogram bisect each other, okay? So remember that when I hear the word bisect, I'm thinking cutting it in two. So we can see that my diagonals come across, and each of my diagonals is bisected, which means that each half is congruent to the other. Now notice that they are not all congruent to each other. Later on, when we talk about a rectangle, the diagonals of a rectangle, when they're bisected, they are all congruent to each other, but a parallelogram, they are not, okay? So the angles bisect each other, but each of the angles are not the same. Not the angles, the diagonals, sorry. Okay, so then we went on and we looked at how I can use those properties to solve for unknown measures or unknown distances of angles. We also worked with knowing that my two consecutive angles are equal to 180. So again, I can set my equations up for that. We looked at being able to use those properties to prove angle or shapes or parallelograms. And then we moved on and we had 21 through 37 odds on page 234. So page 234, 21 through 37 odds. Any questions here?
I had a question on 29 and 33.
29 and 33. Okay, so let's take a look at this. Now remember, what did we learn about a parallelogram? They have two pairs of opposite sides that are congruent, right? So that means that this side is congruent to this side and this side is congruent to this side. Okay? So what does that mean that P is equal to?
5.
5. And so, and then to find Q, I'm going to have Q minus 3 is equal to what?
6.
Good. So then I add 3, so Q is equal to 9. Remember, I've got to understand these relationships. I've got to understand the description of the figure to know how to set up those equations to solve, okay? I know that when it's a parallelogram, I've got two opposite sides that are parallel and congruent, all right? All right, and you said 33 or 31? Alec?
33.
33. Okay, so let's take a look at this one. Let me erase what I've got. Okay, so in this one, we talked about how our diagonals are bisected, meaning they're cut in half. So I know that this side of my diagonal is congruent to this side of my diagonal, and I know that this one is congruent to this one. So again, I can set up equations and I can have 2u plus 2 is equal to 5u minus 10. The reason we did that is because we know those diagonals bisect each other. They cut them in half, which means they are equal to each other. So I'm going to subtract 5u, subtract 5u. I've got negative 3u plus 2 equals negative 10. Subtract 2, subtract 2. Negative 3u equals negative 12. Divide by negative 3, divide by negative 3. So u is equal to 4. Okay, so we find on that one that u is equal to 4. Now we need to go back to the other diagonal. And Alec, how am I going to set that one up? Knowing how he's just set the other one up, what is my equation going to be on this one?
I'm not sure.
You're not sure, okay? Do you understand that when we just set that one up, we said this is equal to this? Are you good with that?
Yes, ma'am.
Okay, why did we say they were equal to each other?
Because
What do the diagonals do? What's the word that starts with a B?
bisect?
Bisect. And what does that mean when I hear the word bisect? It cuts it in half. So that means that both sides are equal, okay? If it's cut in half, then both sides are equal. So we know that that diagonal was bisected. So what does that mean about, let me change my color real quick. What does that mean about this diagonal here? It was also bisected, okay? So I'm going to erase a little bit so we can see. Okay, so if that one's bisected as well, now, Alec, what do you see that we would set up where we would have 6 is equal to v over 3. Are you good with that, Alec?
Yes, ma'am.
Okay, so we're going to set them equal to each other. Now, remember, if I have a number in my denominator that I need to eliminate, a fraction is the same as a division problem. My inverse operation of division is multiplication. Therefore, I would multiply by 3 to get that denominator out of there. Whatever I do on one side, I have to do to the other. So I'm going to multiply both sides by 3. So 18 is equal to V, or V is equal to 18. Okay, so in that one, we set each of our diagonals equal to each other because they were bisected. Bisected means they're cut in half, which means each side is equal to each other. Okay, so hopefully you're seeing kind of the process of being able to translate knowing those properties to being able to turn that into a mathematical equation. Knowing that they're cut in half, I know that one is equal to the other, so I've used the information they've given me and set one equal to the other and just solved it. Okay, does that help?
Yes, ma'am. Thank you.
Okay, you're welcome. Any other questions on this section? All righty, so moving right along. We are going to be moving on to section 6.3 today. Proving quadrilaterals. quadrilaterals are parallelograms. Okay, so we're going to be looking at the different theorems, the different properties that we've just talked about. We're going to look at those some more and try to get that information solid, because knowing these properties helps me to know what kind of figure I'm talking about. All right, so we're going to go ahead and start with our theorems first of all, and we are going to review those. So theorem 6.6 says, if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. In the last section, we said, hey, a parallelogram has these properties. Now what we're doing is we're saying, hey, if I've got a picture of a shape and it has these properties, then it's a parallelogram. So again, we've got our opposite sides are congruent, then it's a parallelogram. If both pairs of opposite angles of a quadrilateral are congruent, then it is a parallelogram. Opposite angles congruent, parallelogram. Theorem 6.8. If my consecutive angles equal 180, then it's a parallelogram. So if my consecutive angles are supplementary, it's a parallelogram. And then the next one, if my diagonals bisect each other, then it's a parallelogram. Okay, so basically in the previous section in 6.2, we said if it's a quadrilateral, then I have these properties. Now we said if I have these properties, then it's a quadrilateral. All right. So we can see here in theorem 6.6, I'm sorry, proof of theorem 6.6, where, and I think we kind of looked at this a little bit in class the other day, where we just said, hey, if we know that AB is congruent to CD and AD is congruent to CB, then ABCD is a parallelogram. And so remember, we talked about how parallelograms or any kind of quadrilateral can be cut in half and it forms a triangle. So basically what they did is they said, hey, here's my given information. We just said that AB is congruent to CD and AD is congruent to CB. And then so we said that, hey, if I draw that diagonal from AC to AC, so if we draw the diagonal from A to C, then we've got that AC is congruent to AC because of the reflexive property. Okay, remember the reflexive property tells me that anything is congruent to itself. So we've shown reflexive property. Now we can see that we've got side congruence here. So we can show that we have triangle ABC and it's congruent to triangle CDA by the side congruence postulate. And then we know that corresponding parts of triangles are congruent. Therefore, we can see that angle BAC is congruent to DCA and angle DAC is also congruent to BCA. So that means that, and we've got AB is parallel to CD, AD is parallel to CB. Therefore, we've got alternate interior angles converse. Therefore, the definition of a parallelogram tells us that our figure is a parallelogram. Okay. Again, we're not going to stress about the right order and all that stuff, but I hope that you can see what we've just talked about, that when I have a parallelogram and a diagonal is drawn, I can see that it cuts it into two triangles. Because I know of a parallelogram, I already have two sides that are congruent to the other two sides that are congruent. When I draw that diagonal, it causes, we use the reflexive property to tell that it's congruent to itself. Therefore, now we have side congruence. Having that, we're able to prove parallel lines. Therefore, we know it's a parallelogram. Okay. All righty. Theorem 6.10 says if one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So now if I just see, if I see a figure and I see that my sides are not only just parallel, but they are congruent as well, then I know that means that these sides are congruent and it's a parallelogram. So we have a flow proof doing the same kind of thing there. We're just going to move on. All right, so this is where I had said we were going to start today, and this is where we're going to dive in. So everything else has been kind of a review. We're starting at goal 2 using coordinate geometry. All righty. So it says when a figure is in the coordinate plane, you can use the distance formula to prove that sides are congruent, and you can use the slope formula to prove that sides are parallel. Okay, so if I've got a question and I need to show that sides are congruent, I can use the distance formula. Distance formula tells me congruence of sides. The slope formula helps me to know that they're parallel. Why does the slope formula help me know that they're parallel? What do I know about the slopes of parallel lines? Anybody remember the slope of a parallel line or of parallel lines will be the same. So if I calculate the slope of each line and it has the same slope, then my lines are parallel, okay? So if you need to make a note of that, you can say, because parallel lines have the same slopes. Okay, parallel lines have the same slopes. So in example 4, we have a figure on the graph, and it says show that A is 2, -1, B is 1, 3, C is 6, 5, and D is 7, 1. And so these are our vertices of our parallelogram. So that has been graphed. And so it says that we are trying to prove that either opposite sides are congruent and so looking at that, or showing that opposite sides are parallel. So if you look at method 1, it says there are many ways to solve this problem. Method 1 is to show that the opposite sides have the same slope, therefore they're parallel. So if we look at the slope of AB, okay, so we're looking at the slope of AB. Remember, our slope formula is M is equal to y2 minus y1 over x2 minus x1, okay? If you haven't memorized that formula, a good thing to do. And so you can see where they said, all right, so if I have A is 0.1 and B is 0.2, then I have 3 minus a -1 over 1 minus 2, and that gives me a -4. Now I look at line CD, and I use the same formula and plug it in. And I say that 1 minus 5 over 7 minus 6. Well, 1 minus 5 is -4. 7 minus 6 is 1. So I've got -4 over 1, which is also just a -4. Therefore, I see that each of my slopes are the same. Therefore, they are parallel. Okay. Same thing with the slope of BC and DA. You can plug them into the slope formula, find that each of the slopes is 2/5. And so I know that if 2 of my sides have the same slope, the other 2 have congruent slopes, same slopes, then they are parallel. Okay, so you can use the slope formula to determine that opposite sides are parallel. The other thing you can do is use our distance formula. Okay, so the distance formula tells me that, and again, I wish they would always write I like to have my original equation. So remember, distance is x1 minus x2, or x2 minus x1, or we'll just say x1 minus x2 squared plus y1 minus y2 squared. Okay, so we've got our basic formula. So again, I'm plugging in AB, and I have 1 minus 2 squared plus 3 minus a -1 squared. When I simplify all of that, I can find that I end up with the distance of that line as the square root of 17. When I look at line CD, I plug in my values again and find the distance of that line is the square root of 17. When I look at BC and DA, again, plugging it into the distance formula, I find that the distance of each of those lines is the square root of 29. As long as my answers are the same, I know that they are congruent. Okay, so in the first one, we showed that they were parallel, and the second one, we just showed that they were the same length. So remember, slope formula tells you if they're parallel, distance formula tells you if they're congruent. So that's how you're going to know which one you need to use. Are you trying to show that they're the same length, or are you trying to show that they have the same slope? Okay. Now, method 3 says that you can use, you can also use both methods to show that one side is congruent and parallel. So you can look at AB and CD, and it says, you can look and say, hey, my slope of AB and the slope of CD is -4, and the length of AB and the length of CD is the square root of 17. So I know that by using both of those together, I have a parallelogram. Okay. So the main thing I hope you're taking away from this talk right now is parallelogram, two opposite parallel sides that are the same distance, or this, so they're congruent. Okay. So let's go ahead and look at our guided practice here. And it says, number 1 is a hexagon with opposite sides parallel called a parallelogram. So how many sides does a hexagon have? Does anybody remember the prefix hexa? How many sides it would have?
6.
6. Okay. Could we consider a hexagon with parallel opposite sides a parallelogram? What type of shape have we learned that a parallelogram is? How many sides does a parallelogram have?
4.
4.
4. So a hexagon cannot be a parallelogram even if the opposite sides are parallel, because a parallelogram is only a 4-sided figure. Okay, so a parallelogram is a 4-sided figure, whereas a hexagon is a 6-sided figure. So we're talking about 2 different shapes. Okay. All right, look at the next one. It says, decide whether you're given enough information to determine that the quadrilateral is a parallelogram and explain your reasoning. So let's look at number 2. What information is this telling me? What do my symbols tell me? That opposite angles are what?
Congruent.
Congruent. I see that I've got one arc for one set of opposite angles, and I have 2 arcs for the other. So that tells me that they are the same measure. They're congruent measures, and they're so opposite angles are congruent. Therefore, I do know that I have enough information to prove that it is a parallelogram. Look at number 3. Number 3 shows me that my opposite angles here, I've got 65 and 65. If this one is 115, what do I know that this angle will be? What is that angle going to be?
115.
It's going to be 115 as well. Why?
Because opposite angles are congruent.
Okay. What if I didn't remember that opposite angles are congruent? What else could I use to know that that would be 115? What do I know about consecutive sides? What do they equal?
Consecutive sides add up to equal 180.
Perfect. Consecutive sides add up to equal 180. So therefore, if I know 115 and 65 makes 180, then that means when I look at this side here, I know I could do 180 minus 65, and that also equals 115. Therefore, because I know that my consecutive sides are supplementary, I'm able to find that that one is also 115. Now I do see that my opposite angles are all congruent. All righty, and then number 4, do I have enough information provided that I've got my arrows showing that opposite sides are parallel?
Yes.
Yeah. Absolutely. If I see that two sides are parallel, I'm sorry, if I see that two sets of opposite sides are parallel, then I've got enough information to say it's a parallelogram. All right, now let's look at 5, 6, and 7. Now it's saying, how would I prove that these are parallelograms? Okay, so think about when we talked a little bit earlier and we talked about proving parallelograms. What information did I have to have, or what using the diagonal, what kind of figure did I turn my parallelogram into two of?
Two triangles.
Two triangles. And remember on that one, we were able to use side, side, side congruence. Okay, so let's look at the figure we have here. They've told me that I've got a congruent side right here. They've told me I've got congruent angles here. So think about between side, 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 angle, 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 side, and a hypotenuse leg. Which of those could I use here? What do I know about this right here?
It's a bisector.
Okay, well, it's not a bisector. It's going to be a diagonal. It would be a bisector of the angles. It would be an angle bisector, but we've got this diagonal. What do we know about if we called that a side? What property tells me that CA or AC is congruent to AC?
The bisector?
Not the bisector. Think about it. I just said that AC is congruent to AC. What property tells me that any... Yes, the reflexive property. Okay. So by the reflexive property, I know that this side is congruent to itself. Therefore, now I have, let me just erase. If I've just said that this side is congruent to itself, I have a side, I have an angle, and a side. So I could use side, angle, side here to prove that I've got congruent triangles. Then using that information, I could show that my angles are congruent. Therefore, I've got a parallelogram. Let's look at number 6. Okay, so they've shown me that I've got angle congruence. Again, what do we know about this diagonal? We know that it's congruent to itself, right? So now if I'm looking at my top triangle, notice I have an angle, I have a side, and an angle. So I have angle, side, angle correspondence here. Therefore, knowing that I've got angle, side, angle, I can show that my two triangles are congruent to one another. Therefore, the angles are congruent, and I'm able to show that I've got a parallelogram. All right, let's look at number 7. What do I know from 7? What information do I know about angle C, angle D, and angle A?
They're all congruent.
They are all congruent. Now I need to focus on angle D. Okay, look at D. How could I solve for X in this problem? What do I know that the angle measure that I have, if I added it to angle X, what would that end up equaling?
180.
That would equal 180, right? Okay, if I added those two together, it's going to equal 180 because I know a straight line is equal to 180. Therefore, once I showed that those angles equal 180, then again, I could use my corresponding angles to show that this would equal 180, this would equal 180, therefore this would equal 180. Okay, so just looking at the measures, thinking about what you know. And then it says describe at least 3 ways to show that A, B, C, D would be a parallelogram. Again, we could use our slope formula, we could use the distance formula, or we could use a combination of slope and distance to find, to prove that it would be parallelogram. Okay, so let's go ahead and look at page 342. Let's do numbers. I want to go ahead and do 9 through 14 here. So you'll just be able to check numbers 9, 11, and 13, and we'll check 10, 12, and 14 at the beginning of class next week. So we're going to do numbers 9 through 14 all. And then we'll move over to page 343. And we're just going to do 17, 18, and 19. So 17 through 19 all. Okay, so that's 9 through 14 all, 17 through 19 all. All right, now we're going to move on to 6-4. 6-4, dealing with rhombuses, rectangles, and squares. All right, so we can see these are special properties of parallelograms. Now think about what have we learned that a parallelogram is an example of? What kind of shape is a parallelogram?
A square?
A quadrilateral, right? A 4-sided shape is a quadrilateral. So that means when I have a quadrilateral, a parallelogram is a type of quadrilateral. Okay, so therefore I know if it's a parallelogram, then it is a quadrilateral. Think about when we talked about, if you've had me the past couple of years with algebra or pre-algebra, and we talked about our sets of numbers. And remember, we talked about how we start out and we've got the set of real numbers, and real numbers we started with our natural numbers. Remember, natural numbers are the numbers that we learned when we were counting. And then we went from natural numbers to whole numbers, and whole numbers were when we added 0 to our counting numbers. And then whole numbers went to integers, where we had positives and negatives on the number line, positive and negative whole numbers. And then we went to rational numbers, which were numbers that could be expressed as fractions. So remember how we said if it was a rational number, if it was a natural number is also a whole number, which is also an integer, which is also which was also a real number. So thinking about kind of that umbrella, or kind of like a hierarchy, that if it's this, then it's this, then it's this. We're doing the same thing here. So we're saying, hey, I'm talking about quadrilaterals. I'm talking about 4-sided figures. And then we said, hey, an example of a 4-sided figure is a parallelogram. So now we're talking about types of parallelograms. So if I'm talking about a rhombus or a rectangle or a square, I'm talking about a parallelogram. And if I'm talking about a parallelogram, I'm talking about a quadrilateral. Okay, does everybody follow? So just because a shape is a square, just because a shape is a parallelogram doesn't mean necessarily that it's going to be a square. But if it's a square, then it is a parallelogram. So looking at those kind of like those if-then statements. Oh, here comes Easton. So looking at those statements, we're kind of thinking about what we've got. So we said that a quadrilateral, an example of that would be a parallelogram. And now with our parallelogram, We're looking at 3 different types, and we're looking at the rhombus, at the rectangle, and at the square. Okay, so that's what we're going to focus in on right now. Hey, Easton, we are starting on page 347. We are just starting section 6.4. At the break, I'll go over and tell you the homework questions that we need. Okay, so, and actually, I tell you what, before we dive in too deep, let's go ahead and take our break a couple of minutes early. And then that way I can get Easton caught up and we won't go too far. All right, so go ahead and take a 5-minute break. Easton, we kind of did a walkthrough, kind of a review of chapter 6, where we are so far. We had covered 6.1, 2, and part of 3. We picked back up after looking at those. The place where we started was goal 2 on, let's see, that was page 341. And we just talked about if I have a diagram graphed, if I want to show that, huh?
I was just like agreeing.
Okay. Okay, cool. So we looked at that if I graph a parallelogram, then I can look and prove that my sides are congruent by either using the slope formula or I can use the distance formula. Okay, so the slope formula tells me my slopes are the same, therefore they're parallel lines. My distance formula tells me that the length is the same, therefore they are congruent. And we know that 2 pairs of opposite sides that are congruent and parallel make a parallelogram. So our homework in that section on page 342, we have 9 through 14 all.
Yeah.
And then on 343, we have 17 through 19 all. Okay, so that'll be my homework for those sections, for that section. And then we were just moving on to 6.4, talking about rhombuses, rectangles, and squares. And we were talking about how we started out talking about quadrilaterals, and then we talked about a special type of quadrilateral, which is a parallelogram that has 2 pairs of opposite congruent parallel sides. And now we're talking about examples of parallelograms, a rhombus, a rectangle, and a square. And we said that just because a figure is a quadrilateral doesn't mean it's a square, but if it's a square, that means it is a parallelogram and it's a quadrilateral. Okay?
Yes,
So
ma'am.
that's what we're going to be picking up.
I just read the email wrong. I was like, oh, class is canceled. I was like, oh, I thought it was like today too. So I was like,
Oh, I'm sorry. No,
oh,
then I should have.
no, it's fine.
So anyway, yeah. So you've just missed a review. So that's we spent the first half of class kind of reviewing back from 6.1. We started at 6.1 and kind of walked through and did a review. We also answered a couple of questions. Did you have any questions from the homework? Let's see. We had on page 320. Let's see, 320 or 334. We had 21 through 37 odds. Did you have any questions? Actually, there was a page before that. Where am I?
327, 39 through 45.
Yes, 327. And then, so we had 37 through 45 odds. Any questions on those?
21 through 37, I'm fine on. And then the only problem I have a question on is 39.
Okay, so on 39.
On 39 through 45, page 27. That's the problem I have one on.
Okay, so remember that what do we know that our total interior angles of a quadrilateral equals?
180?
Not 180. That's the total of a square. Okay, so and actually one of the things that I kind of told everybody to think about, if I've got a rectangle, what do I know about the angles of a rectangle?
They're all equal.
They're all equal. And what kind of measures are they?
90s.
90 degrees. How many 90-degree angles do I have in a rectangle?
4.
4. What's 4 times 90?
360.
360. So every quadrilateral, the interior angles equals 360. Okay. So if I know that angle A plus angle B plus C and D equals 360, then I know that I'm going to let angle A be X. So I'm going to have X plus 85 plus 63 plus 87 equals 360.
Oh, that makes sense.
Okay,
I
so
was-
all
I-
you do is, yeah,
Yeah, I was like really confused. I was like, how do you do that? I was like, it makes no sense. And I was like, wait, there's
yeah. So the
something I'm
first thing you
missing.
have to remember is that if I add them all up, they're going to equal 360. Okay, so now that you know how to do that one, you can go back and look at it. Now let's look at the next section. And again, it's the same thing here. If I know that when they're all added up, they equal 360, when I look at number 41, again, I'm just going to say 100 plus X plus 87 plus 106 equals 360. And I solve for X. So that's all you're doing. So even like number 45, you can see where we worked out that one just a minute ago. So even though my angle measurements look weird, I've got 25x minus 2, I still set it up the exact same way where angle 1 plus angle 2 plus angle 3 plus angle 4 equals 360. So I add up the angles that I have, I use the variables, combine like terms, and solve.
All right,
that-
thank you.
Okay,
Yes,
so
ma'am.
go back and work through those. If you have any questions after you've worked them, text me, email me, let me know, and I'll be happy to help you. Okay.
Yes, ma'am.
Yeah, but
Thank
all you
you.
need to know for those is that they add up to equal 360. And then 6-2, we had 21 through 37 odds on page 334.
Yes, ma'am.
Any questions
Um,
there?
No, ma'am, actually. I was actually really confident in that section.
Good, good, good. So yeah, so knowing opposite angles are congruent, knowing that opposite sides are congruent, you're able to just set up an equation and solve.
Yes, ma'am. Thank you.
You're welcome. And so I think, and so now we've got 9 through 14 all on 342, 17 through 19 all on 343. And you are called up. All righty. So rhombuses, rectangles, and squares. Now, one of the things that hopefully you figured out by now is as we look at a new shape, it is going to be to your benefit to really absorb the things that make each shape what it is. Knowing that, am I dealing with congruent sides? Am I dealing with congruent angles? Am I dealing with all sides have to be congruent? Am I dealing with only two sides have to be congruent? Am I dealing with they have to be 90-degree angles? Whatever it is, and that's what's going to help you be able to differentiate between the different types of shapes that we're dealing with. So then when you see a picture, as you'll see in your homework, where it'll give you a picture of a shape, and you're going to have to know how to figure out what it is based on the properties of the shape. So the first one we're looking at is a rhombus. And it says a rhombus is a parallelogram with 4 congruent sides. That's it. Okay. It says nothing about angles here. The only way I can show my rhombus is that it is 4 congruent sides. We've always kind of talked about how a rhombus looks like it would be a square, but it looks like maybe something heavy sat on top of it and kind of shifted it down. So I can see that my angles are not all congruent, but I see that all of my sides are congruent. Okay, so that's going to be a rhombus. A rectangle is a parallelogram that has 4 right angles. Okay, so I can see that those parallel sides, remember, all of these are going to have 2 pairs of parallel sides because we've said they're parallelograms. And that is our trait of a parallelogram. It has 2 pairs of opposite parallel sides. Okay. So now my rectangle has 2 pairs of opposite parallel sides and it has each angle is 90 degrees. Now, when I look at a square is a parallelogram that has 4 congruent sides and 4 right angles. Okay, so a square basically is a rhombus and a rectangle put together. It has to have 4 congruent sides. It has to have 4 90-degree angles to make it a square. Okay, so just like we talked about a moment ago, a square is a rhombus, a square is also a rectangle, and a square is also a parallelogram, and it's also a quadrilateral. So when I look at all of those things, it has all of the traits. Excuse me. So you can see here the Venn diagram that it shows. It says, hey, if I'm looking at rhombuses and rectangles, that overlapping part is the square because it's going to be part of both groups. And they are all part of the parallelogram family. All right, so example 1 says, describing a special parallelogram. Decide whether the statement is always, sometimes, or never true. Okay, a rhombus is a rectangle. A rhombus is a rectangle. So what do I know a rectangle has to have? It has to have 2 pairs of opposite parallel sides, and it has to have 90-degree angles. Okay, so if we look at our solution, it says the statement is sometimes true. In the Venn diagram, the regions for rhombuses and rectangles overlap. If the rhombus is a square, then it's also a rectangle. Okay, so remember that if I have a rhombus that is in the shape of a square, then it can be a rectangle. It can also not be, so that way it's going to be a sometimes statement. Look at letter B. A parallelogram is a rectangle. Well, that's true. It could be a rectangle sometimes, but it could also be a rhombus. So we know that it is sometimes true because it could be a rectangle or it could be a rhombus. Okay, so that's where we would say sometimes true. Now, what if I had a statement, a triangle is a parallelogram? Would that be sometimes, always, or never? Nobody wants to jump out there. It's going to be never, because remember, a triangle is 3 sides. A parallelogram is 4 sides. So a triangle is never a parallelogram. All righty. Let's go ahead and look at example 2 on the next page, page 348. It says ABCD is a rectangle. What else do you know about ABCD? So the picture they've shown us is that I have 4 90-degree angles. That's all they've told us. But it says because ABCD is a triangle, it has 4 right angles by definition, and that's what they've shown us. The definition also states that rectangles are parallelograms. So ABCD has all of the properties of a parallelogram. And remember, our properties of a parallelogram is that opposite sides are parallel and congruent, opposite angles are congruent, and consecutive angles are supplementary, and that diagonals bisect each other. Remember, that was what we talked about in 6.2 and 6.3, is that if it's a parallelogram, opposite sides are parallel and congruent, opposite angles are congruent, and consecutive angles are supplementary, meaning they add up to equal 180, and that diagonals bisect each other. A rectangle is defined as a parallelogram with 4 right angles, but any quadrilateral with 4 angles is a rectangle because any quadrilateral with 4 right angles is a parallelogram. Okay, so any quadrilateral with 4 right angles is a rectangle. So even if it's a square, it's also a rectangle because it has 4 right angles. Because any quadrilateral with 4 right angles is a parallelogram. So it says in exercises 48 through 50, you will justify the following corollaries to the definitions of a rhombus, a rectangle, and a square. Okay, so we have these different corollaries that says a quadrilateral is a rhombus if and only if it has 4 congruent sides. The rectangle corollary says a quadrilateral is a rectangle if and only if it has 4 right angles. And the square corollary, a quadrilateral is a square if and only if it is a rhombus and it is a square, meaning it has 4 congruent sides and it has 4 right angles. Okay, so that's what they're saying there. 4 congruent sides, 4 right angles. All right, so I can use that information to prove if something is a rhombus, a rectangle, or a square. Okay, example 3 says using properties of a rhombus. In the diagram at the right, PQRS is a rhombus. What is the value of Y? So let's look at our diagram. They've told me it is a rhombus. What do I know is true about a rhombus? A rhombus has 4 congruent sides. So knowing that, I know that this side is equal to this side. Therefore, I can set up an equation where 2y plus 3 is equal to 5y minus 6. And then I just solve for y. Subtract 5y, subtract 5y, negative 3y plus 3 equals negative 6. Take away 3, negative 3y is equal to negative 9, divide by negative 3, divide by negative 3, and y equals 3. So that's exactly what they did over here on the other side, except for notice they set it up where they have 5y minus 6 is equal to 2y plus 3. So it doesn't matter which side we set up to be equal to whatever. The main thing is that I have one is equal to the other. No matter if I flip-flop it, there's no magic in setting up my equation. Just as long as I set it up to where I have one equal to the other, it's still going to solve to show that y is equal to 3. Any questions about that? All righty. So goal 2 says using diagonals of special parallelograms. So now we're focusing on the diagonals of a rhombus and a rectangle. So if we look at our diagonals, it says a parallelogram is a rhombus if and only if its diagonals are perpendicular. All right, so think about perpendicular. What should come into your head when you hear the word perpendicular? They intersect at what kind of angle?
Right angle.
Right angle. And a right angle is equal to 90 degrees. Okay, so when I see this and I've got 2 pairs of opposite parallel sides and I see diagonals that intersect at a 90-degree angle, I know I'm dealing with a rhombus. The next one says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. All right, so if I look at my diagonals, not only do we know that since it's a rhombus, they're going to be perpendicular diagonals, but also they are bisecting the opposite angles. So therefore it is a rhombus. And then the last one says a parallelogram is a rectangle if and only if its diagonals are congruent. So notice here, when I have my diagonals, they intersect. They are not intersecting at a 90-degree angle. We can see that those angles are not congruent, but my diagonals are congruent. So that means that they are both bisected, but each little segment is the same measure. Okay. So by looking at this information, I know that if I was talking about a square, then I could apply all of this to a square, that the diagonals would intersect at a 90-degree angle, that the diagonals would bisect each angle, and that the diagonals would all be congruent. That's going to be for a square. Since a square is a rhombus and a rectangle, then I know that all of these would apply to the square. But just the rhombus, they are perpendicular and they bisect the angles. But with a rectangle, they are all congruent. All right, let's look at proving theorem 611. Uh-oh. Lost my screen, hang on. Come on. There we go. All righty. Okay, so it says write a paragraph proof of the converse above. So basically it's just saying that ABCD is a rhombus and we need to prove that AC is perpendicular to BD. And so in paragraph proof form, it just restates the given that ABCD is a rhombus. So AB is congruent to CB. And since ABC is a parallelogram, then we know that the diagonals bisect each other. So we know that AX is congruent to CX and that BX is congruent to BX. And then it says use the side-side-side congruence postulate to prove that the triangles are congruent. If the triangles are congruent, then those angles are congruent. And because AC and BD intersect to form congruent adjacent angles, then we know that they are perpendicular. Okay. So again, just kind of looking through that, understanding what that shape, what all that information is telling us. All right, coordinate proof of theorem 611. So remember that if I graph a shape into a coordinate grid, then I know that usually I'm going to be looking at my distance formula, or I may need to use slope. If remember, slope tells me if I've got parallel lines or not, or I could tell perpendicular lines. But if I'm looking just for length, I know I'm dealing with distance formula here. So basically it says that if you were to graph a parallelogram, and then you looked at it, then you could set up and use your distance formula to show that all of them are congruent. Now notice in this particular example, they did not tell us the exact coordinate number. So when you put it into that distance formula, you've actually got variables left. And so it said, because we have OA as the coordinates of A and BO as the coordinates of letter B. And so when you set up everything on that grid, they're not telling us the exact numbers, okay? Checking a rectangle. Okay, so think about a rectangle. It says you're building a rectangular frame for a theater set. First, you nail 4 pieces of wood together as shown at the right. What is the shape of the frame? So if I nail them all together, my opposite sides are the same measures, then we know it's a parallelogram, right? So just because I've got all 4 measures the same length doesn't mean that it's going to be a parallelogram. But it says to make sure the frame is a rectangle, you measure the diagonals. So it says one diagonal is 7 feet 4 inches and the other is 7 feet 2 inches. Therefore, is it a rectangle?
Opposite sides aren't congruent.
Okay, the opposite sides are congruent, so therefore we know it's a parallelogram. But remember, what was our rule about a rectangle and the diagonals of a rectangle? Remember
The diagonals would be congruent.
the diagonals have to be congruent as well. But what does it say that one diagonal is? One is
4.
7 feet 4 inches, and what's the other? 7 feet 2 inches. Are my diagonals congruent?
No, ma'am.
No, they're not. So somehow when they nailed together those boards that are the same, it's a little off. So it's going to be a parallelogram, but it won't necessarily, it's not going to be a rectangle because it's going to be a little tilted if my diagonals are not the same, okay? They would have to make sure that they've got it all leveled up and make sure that I've got 4 90-degree angles. If everything was set where I had 4 90-degree angles, then my diagonals will be exactly the same, okay? So in this example, because they told us our diagonals are not the same, then it is not a rectangle because my diagonals are not congruent. It would be a parallelogram, just not a rectangle. All right, so let's go ahead and look at this. It says, what is another name for an equilateral quadrilateral? Okay, so let's think about what was our quadrilateral that we learned has 4 congruent sides. Which quadrilateral has 4 congruent sides? Huh?
Rhombus.
A rhombus. Good. Very good. And so let's move on to there are always, sometimes, and never in number 3. A rectangle is a parallelogram.
Always.
Always. Number 4, a parallelogram is a rhombus.
Always.
Not always. Remember, a parallelogram could be a rhombus, a rectangle, or a square. So it's just sometimes a rhombus. Now, a rhombus is always a parallelogram, but a parallelogram is not always a rhombus. It's just sometimes a rhombus. A rectangle is a rhombus.
Never.
When could it be a rhombus? If that rectangle was a what? Remember, if my rectangle is a square, then it could be a rhombus because a square is both a rectangle and a rhombus. So that would be a sometimes. What about a square is a rectangle? Again, that one's just going to be sometimes because a square could be a rectangle. It could be a rhombus. So that's just going to be sometimes. I'm sorry, I said that backwards. A square is always a rectangle. Okay. A square is always a rectangle and it's always a rhombus. It's just that sometimes a rectangle would be a square and sometimes a rhombus would be a square. So a square is always a rectangle. All right. Which of the following quadrilaterals have the given property? Which one has all sides congruent? A parallelogram, a rectangle, a rhombus, or a square?
A
And
square.
there's a square and
Rhombus.
a rhombus. Good. So for that one, it would be rhombus and square. Look at number 8. All angles are congruent.
Rectangle.
A rectangle and which other one has congruent angles?
Square.
A square. Good. A rectangle and a square. They both have 90-degree angles. Therefore, they're congruent. Look at number 9. The diagonals are congruent.
Rhombus.
Not a rhombus. Think about diagonals being congruent. That means that they have to be the same measure the whole way.
Rectangle.
Huh?
Rectangle.
Rectangle and what else? What other one would have congruent diagonals?
Square.
Square.
A square. Good. A rectangle and a square again. Okay. And which one or ones have opposite angles that are congruent?
Parallelogram.
Parallelogram and what else? Opposite angles are congruent. If it's a parallelogram, we said that we know that the opposite angles are congruent. What about a rectangle? Are opposite angles congruent on a rectangle?
Yes.
Yeah, because they're
Yes.
90 degrees. What about a rhombus? Opposite angles are congruent again on a rhombus, and same with a square. Okay, so all of them have opposite angles are congruent. Okay. Since a square, a rhombus, and a rectangle are all parallelogram, we learned that parallelograms have opposite angles that are congruent. So it applies to all of them. So let's look at MN PQ is a rectangle. What is the value of X? So what do we know about my angles of a rectangle?
They all equal 360.
Okay, they do all equal 360. And what is each angle measure?
90.
These are all 90 degrees, right? So how can I figure out what X is equal to?
Set 2x to 360.
No.
2x plus 90.
Okay, so you could say 2x plus 90 plus 90 plus 90 equals 360. That's one way, but what's an easier way? What do I know that 2x is equal to?
90.
90.
Yeah, 2x is equal to 90 degrees. So instead of having to add the 90, 90, 90 and 2x and subtract it all from 360, I can just do divide by 2, and I see that x is equal to 45 degrees. Since I know that that angle equals 90 degrees, then 2x is equal to 90, so x is equal to 45. All righty. So in this section, let's look at, it says, let's start with on this one, let's just do numbers 17, 19, and 21. So 17 through 21 odds. So this is page 351, 17 through 21 odds. And basically here, you're just looking at each of your shapes, and the directions say list each quadrilateral for which the statement is true. Okay, so it could be one, it could be more than one. You're just looking for which one the statement is true. All right, let's look at the next page on 352. On 352, let's do numbers 33 through 41 odds. 33 through 41 odds. So look at the first section, 33 through 38 or 37. It just tells you what each shape is. You're going to need to use the information that you know about each shape to determine each value. Now, it could be that they've given you information. Look at number 33. What kind of shape do I have?
Square.
It's a square. What do I know about each angle of a square?
90 degrees.
90 degrees. Do I even need to know that that diagonal is 18 degrees?
No.
Or that it's equal to 18, the distance is 18? That's not going to play into how I solve my problem at all. Okay, so be real careful. Look at just the information that you need to use. So that's 33 through 37. You're just looking at using the information that you know about each shape to set up an equation. And then for 39 and 41, we see that we have a square with diagonals that intersect at L. They have told us that GH is equal to 2 and GL is equal to the square root of 2. Okay, so they've shown us that our sides all equal 2 and that my diagonals all equal to the square root of 2. So for 39, you're just telling what does HK equal? And for 41, you're telling the measure of angle HJG. So think about your properties of a square to be able to determine those. All righty. Go ahead and turn to 6.5. Okay, so 6.5, we're talking about trapezoids and kites. Okay, we're not going to cover all of this section. I may end up ending a little bit early today just because I don't want to give y'all too much at one time. So just to kind of give you an idea of what our path is right now. In this chapter, we have 6.5, 6.6, and 6.7 left. Okay, my goal is that by the time we end on Thursday of next week, by the time we get out for Christmas, you will be getting a test on chapter 6, and then it will be due so what I may end up doing is we may actually do an in-class test next Thursday, because we can wrap up this chapter. I don't want to do that. I don't want to do an in-class test. I just want you to have that. I want you to have enough time to really take everything in. So we'll be wrapping up the chapter by Thursday, if not before, and we may kind of finish it up a little bit on Wednesday. So that's what we'll do is that'll just give us a good time to do some review in class. There may be some time to start the test in class, and then you'll have the option of working on it then or waiting. So we'll kind of play that year. But basically what would happen is your test would just be due. You would have to submit it online by the next week. Okay. So know that we're going to end the semester with chapter 6 test, and that you'll just either email it or post it on the website. And that would be our final grade for the semester. So with that being said, we need to talk about the homework. Then what we will plan on doing is all of your homework will be due for chapter 6 on Thursday of next week, whatever we have had up until that point. So that means on Wednesday, we may just go ahead and do our homework in class. Let me work those things out timing wise, or it just may be that whatever we have for homework Wednesday will not be due. I don't know. We'll figure that out. That's the hard part about having the 2 classes side by side, having it Wednesday and Thursday. So anyway, we'll figure that out. Claire?
I was just wondering when you want the chapter 6 test due.
So the chapter 6 test would be due by the following Thursday. So what is that? The 17th? We get out on the 10th. Is that right?
I think so.
So if Thursday is the 10th, then the next Thursday would be the 17th, I think. So it would just be it would either need to be uploaded or emailed to me by that Thursday. So that would give you a week to work on it. So we'll kind of iron out those details based on how far we get next Wednesday. It'll all kind of depend on how far we get by next Wednesday. The main thing that I want you to know is that by next Wednesday, the homework that is due will be 6-1, 6-2, 6-3, and 6-4. Okay. I don't plan on giving you homework on 6-5 today. So those 4 sections of homework will be due 1, 2, 3, and 4. Hopefully you've already done those, checked them. Just make sure you've got all that. Oh, did I lose Easton?
And we'll be in class next week, right?
Yes. Next week we're back at the co-op.
I'm sorry. It said that I was removed from the meeting.
Oh, I'm sorry.
It's fine. It's fine.
I didn't kick you out, I promise. Or I didn't do it on purpose. Okay. So like what we were just saying was we were figuring out what homework is due next Wednesday. So next Wednesday, I will be taking up homework for 6-1, 6-2, 6-3, and 6-4. Okay. Then I'll be giving you a test on Thursday that will be due the next week. You'll either upload it or email it. And then, and I'll email all this since I'm a little rambly right now. We'll just to make sure that everybody's on the same page. I'll send an email out in just a few minutes that tells all this, so we're all clear about what's due on Wednesday. You'll have a test go home Thursday. It'll be due the next Thursday. We're going to go ahead and talk about 6-5, but we're not going to go all the way through it today, but we'll finish it up next Wednesday. All right, so trapezoids and kites is what we're talking about. So now we know a trapezoid is a quadrilateral that only has 1 pair of parallel sides. Okay, so a trapezoid has 1 pair of parallel sides, because what is our figure that has 2 pairs of parallel sides? What have we just talked about? A figure that has 2 pairs of parallel sides.
The parallelogram.
As a parallelogram. Okay. So remember, we've talked about quadrilaterals. And so now we said that we have parallelograms. And now we're looking at trapezoids. Okay. So our parallelograms have 4, I'm sorry, not 4, has 2 pairs of parallel sides, and a trapezoid has 1 pair of parallel sides. Okay, so that's where we're still talking about quadrilaterals, but now we're talking about quadrilaterals that only have 1 pair of parallel sides, and that is called a trapezoid. Okay, so a trapezoid, we have the bases. Your bases are always going to be the sides that are perpendicular. Okay, so notice that those are the sides that have the arrows. All right, I said perpendicular, I'm sorry, parallel. If they have the arrows, that indicates that we've got parallel sides. The parallel sides are always going to be my bases. My 2 sides that are not parallel are going to be called my legs. Okay, sometimes the legs are the same measures, sometimes they're different measures. If my legs are congruent and they're the same measure, then I'm talking about an isosceles trapezoid. Remember how we talked about an isosceles triangle was one that had the 2 sides congruent? Same thing with isosceles trapezoid. If I have my 2 legs are congruent, then it's called an isosceles trapezoid. Sometimes they will be congruent, sometimes they won't be. Okay. The main thing about a trapezoid, though, is that my 2 bases are parallel. Now we're going to look at our theorems for trapezoids. First of all, it says a trapezoid is isosceles when if a trapezoid is isosceles, then each pair of base angles is congruent. So if it's isosceles, that means that my sides are congruent. Therefore, my base angles are going to be congruent. 615 says if a trapezoid has a pair of congruent base angles, so if I have these congruent base angles, then I know my sides are congruent. Okay. And then a trapezoid is isosceles if and only if its diagonals are congruent. So that means that this diagonal and this diagonal are congruent. Okay. So if a trapezoid is isosceles, each pair of base angles is congruent. If a trapezoid has a pair of congruent base angles, then it is an isosceles triangle. A trapezoid is isosceles if and only if its diagonals are congruent. So these are properties of isosceles trapezoids. Okay, so let's look at this in example 1. So we have our trapezoid, and it tells me that it is an isosceles trapezoid. So we need to find the measure of angle P, the measure of Q, and the measure of R. Okay, so if I'm looking at R first, what do I know the measure of R is going to be, and why do I know that? What is the measure of angle R going to be?
50.
50. Why?
Because those like little dash marks are the exact same.
Yeah,
So
because my sides are congruent. And so if I know that my sides are congruent, I know that the base angles are congruent. Okay. So remember, our bases are my parallel lines. Sometimes my bases will be top and bottom. Sometimes they're going to be side to side. We've just got to look and see which set are parallel. Okay. So I think a lot of times we get hung up on base means bottom, and that's not necessarily going to be the case here. So I know that my base angles are congruent. Therefore, I know that angle S is 50 degrees, so angle R is 50 degrees. Okay. So if those are each 50 degrees, how could I find out angle P and angle Q? What do I know that they all add up to equal? The 4 angles of a quadrilateral equal what?
360.
360. Okay. What is 50 plus 50?
100.
100. So what does that leave?
130 for both of them.
130 for both of them. I know that I have 260 degrees left to divide amongst 2 angles. Also remember that we learned that we've got consecutive angles are supplementary. That means they add together to make 180. So if R is 50 degrees, I know that Q is going to be 130 degrees because 130 plus 50 is 180. Same thing here. I know that these are going to be supplementary. So I've got 130 degrees. But also my base angles can be talking about the angles at the top and the angles at the bottom. Okay, so since the base angles are congruent, I know that 50 and 50 are going to be congruent, and so 130 and 130 are congruent. Questions about that? All right, using properties of a trapezoid. Now notice it talks about, so if I have graphed my trapezoid and I want to show which sides are my parallel lines. Remember, parallel lines have the same slope, so I can use my slope formula. And I can look and see that AB is congruent to is parallel to CD because they each have a slope of -1. I can also see that the slope of that the slope of BC is congruent to the slope, I keep saying congruent, good grief. Yes, it's congruent to the slope of AD, therefore they are parallel as well. So when I have two sides of parallel, good night, I'm saying this all wrong. Let me start over. The slope of AB is congruent to slope of CD. Therefore, those are parallel sides. Okay, they are congruent, therefore they're parallel. BC and AD, my slopes are not the same. So I know that those are not parallel sides. If I wanted to find the distance, I could use my distance formula to find what those lengths are, but I know that CD and AB are going to be my parallel sides because they have the same slopes. So if it was asking me to find which sides were parallel, I would use my slope formula to figure that out. Okay. Let's stop there because I seem to be getting quite tongue-tied and messed up. So we will pick up with mid-segment. So this is, I'm going to make myself a note to start here on 12. Okay, so let's see. Monday is the 7th. So Tuesday is the 8th. So Wednesday is the good night. It's the 9th. Okay, so we're going to start with mid-segment on the 9th. We will finish up chapter 5, section 5. So we'll talk about the mid segments of a trapezoid. We will look at kites. Then we will move on to 6.6, talking about summarizing the properties of quadrilaterals. So in that, we're going to be talking about parallelograms, rhombuses, rectangles, squares, trapezoids, all that good stuff. So we're going to kind of be reviewing a bit of that. And then in 6.7, we're going to be talking about area. Okay, so think about when we talk about area of a figure, we're talking about what is the, how much space does it cover? Okay, so remember, perimeter talks about the space on the outside, but then area talks about how much space does it cover, does the entire shape cover? So we'll be moving on to talk about area, okay? So 6.6 is super short, so we've got just a little bit of 6.5, we've got 6.6, and then we'll spend a bulk of our time on Wednesday dealing with area. On Thursday, we will finish up with that. We'll do a review and get ready to talk about the test. One of the things that I will do is I will go ahead and for the chapter 6 test, I will go ahead and make it open book. And I also will probably go ahead and add in a few cumulative questions that deal with what we've looked at so far this year. It won't be anything major, won't be anything, but it will be, I'll go ahead and make it open book, but there's just a couple of things that I want to make sure that before we wrap up this semester that you remember. Maybe some information about triangles, but it's all going to be some basic stuff. And I'll also put some bonus extra credit stuff on there as well. So if you're needing to kind of pump up your grade, I think everybody's doing well though. But anyway, we'll go ahead and I'll throw some extra credit on there. So we'll have a couple of, maybe a question or two from previous sections or from previous chapters. And then, so anyway, we'll talk more about that. I'll have it prepped. So next Thursday, we can look at it, talk about it. And like I said, I'll go ahead and make it open book since this has been such a crazy semester and we've been back and forth about in class and out of class and whatever else. All right. So I guess we're ending about 5 minutes early. Any questions about what's due? Go ahead and if you get a chance to finish up that homework or to work on the homework today, that's great. So we can ask questions tomorrow. If not, not a big deal. All right. Well, if anybody doesn't have any questions, we'll go ahead. Clara?
Bye, Miss
I have one
Jennifer.
question. Are we doing 6.5 homework or not?
Okay, so 6.5, we've got to finish up 6.5. So we will not have homework on 6.5, right?
Okay. And I think
Yes.
6.1 and 6.2 are already done.
Perfect. So really, and today we checked, yes. So remember, so next week, and like I said, I'll send an email in just a minute, just saying that next Wednesday, 6, 1, 2, 3, and 4 is due. We'll wrap up 6, send a test home on Thursday, and be done with half of the book by Christmas. Okay. If you have questions between now and then, be sure to let me know. I'll send a quick little email in just a minute to y'all to remind y'all of all that. And then I will see y'all in class next Wednesday. Okay. I hope everybody has a good week. If you have questions, please don't hesitate to reach out and let me know. I'm happy to help you.
Thank you.
You're welcome. Thank you guys. See y'all next week. Bye-bye.
Bye.